This is the study guide for Algebra B, Test 3 of quarter 3. And so if you look at the first three problems, you'll see that all they're asking us to do is find the roots. Well, basically we need to figure out what these roots are. Well, roots are x-intercepts. So when you see the word roots, think of x-intercepts, where the graph crosses the x-axis. And that's all they're really looking for when they're dealing with these quadratics. And they're asking for solutions. That's what we want. And so you look to see where it crosses, and it crosses right here and here. And so you just name those points along the x-axis. And so this one is 0, and this one is 1, 2, 3, 4 spaces over. So our answer is 0 and 4. And those are the roots, the x-intercepts, solutions they also call them, or zeros sometimes they call them. So in this case we had two answers. And that's the most you can ever have for solutions when we're dealing with a quadratic. But we can also have a number of different answers. We could have two answers, or in this case, here we only have one solution. See, it only crosses right there. And that one point is called the vertex. This is the vertex because that's where this graph is changing directions. And so in this case, we have a point that is 1, 2, 3, 4, 5, 6, 7 spaces to the left. So we say we only have one solution, and that is -7. So the next problem, we look to see where this graph crosses, and it comes up, and then it just never does get to the x-axis, and then it comes back down. So here, since there's a gap, there's no x-intercept. And when there's no x-intercept, we can say that there is no solution, because solutions are x-intercepts. So we can say it a few different ways. You can say no solution, no x-intercepts. And we could also use a 0 with a slash through it, means no solution. We can also say the empty set. The empty set is a set of values. Well, a solution set is a set of values that end up making answers that agree with the situation that you want to make. Well, here we don't have any solutions because we don't have any x-intercepts. So we can call this the empty set, and you just have a set of braces with nothing inside. So the first three problems, that's all they're asking is, what are the solutions? Here, the next three problems, they're asking us to graph. And so the way I asked you to go about graphing was using this vertex formula, and then from there using the parent graph. And so the vertex formula goes this way: x equals -b over 2a. And we'll learn later on where this little formula comes from, but for right now we just need to understand what the b and a terms are. So let me write out what the quadratic equation is. It's ax squared plus bx plus c, and that all equals a variable like y. And so when you have y by itself, then you have your x squared term, your x term, and your constant. A is the coefficient in front of x squared, b is the coefficient in front of x, c is the constant itself. Well, in the formula for the vertex, all we need is this b term, which is the coefficient of x, but we don't see it here. And so when you see no b term, that means that the b term is 0. See, I could rewrite this as y equals -2x squared plus 0x plus 3. So when you have no b term, we have 0 over 2 times by -2. Well, 2 times by -2, that doesn't really matter because you're going to end up with an x value of 0. So this x value is the x component of this vertex. Well, from there, you're just going to substitute 0 back in for x to find y. So y equals, and then you have that -2 times by 0 squared plus 3, which the 0 ends up canceling out the x term altogether, so you're just left with 3. So our vertex is 0, 3. So that's where you're going to start this graph. So you go over 0 and then up 1, 2, 3 spaces. So you'll notice whenever you have just an x squared and constant, your vertex is always going to be on this y-axis. And then from there, what I use is the parent graph. You see this positive 3 moved the graph. This is what makes the shape right here. And so the shape's going to be a U-shaped graph. It's just going to be a little bit more narrow. And it also tells us that it's going to be upside down because we have a negative sign in front of the x squared. So here's what I do for the parent graph. And so I end up using just that part. But now instead of having to plot points, I'm just going to go from the vertex. And I'm going to pick values for x, and that's the direction I'm going to go, is the x direction, the number of spaces that I pick. So I'm going to only pick two numbers. I'm going to pick 1, because when I pick 1, I also end up getting negative 1 as well, because when you square 1, you get 1. When you square negative 1, you get 1. Times by negative 2 gives me negative 2. So this means from the vertex, and you always go from vertex when you're using this parent graph. I'm going from the vertex, I'm going to go one space in the x direction, one space in the x, and then I'm going down 2. And I can do that on the other side, one space over, down 2. So that gives me 2 points. And I can do the same thing with 2. You see, if I square 2, I get 4. Times by negative 2, I end up getting negative 8. So what that means is 2 spaces in the x direction. So again, this is the x direction, 2 spaces over, 1, 2, down 8. So that's 3, 4, 5, 6, 7, 8. And then you put the point. Do the same thing on the other side. 2 over, to the left, down 8. And again, you can do that because when you square negative 2, you get the same answer. And using the parent graph, you always go from the vertex, not back to the origin. So you only need to plot 1 point using the x and y values, the x and y components for an ordered pair. But then from there, we can use the vertex to just tell us which direction to go and then plot points. It's very similar to using the slope and y-intercept. Once you have the y-intercept, you can use the slope to graph points. Very similar concept. Same thing here. So we learned in the last problem, whenever there's just no x value, that means that our x value of the vertex is 0. And so our y-intercept is going to be negative 5. And so that's where our vertex is going to end up starting. So down 5 spaces. 1, 2, 3, 4, 5. And then from there, we just use the parent graph. So the parent graph is a y equals x squared. Well, when you square 1 or negative 1, you get the same answer. So you just get a positive 1. So again, from the vertex, over 1, up 1. Over 1, up 1. And if I square 2, I end up with 4. If I square negative 2, I also end up with 4. So you go over 2 spaces from the vertex, up 4 spaces, and it gives you 2 points. And from there, you can draw the graph. And so that's the power of the parent graph, is it gives you points quickly, just like power of the slope-intercept form. Using the slope gives you points quickly. So it just eliminates having to plug in an x value for each of these x's and then going ahead and solving. Well, this problem, we're going to end up needing that axis of symmetry formula, negative b, which is, in this case, 8, so the opposite of 8, over 2a. Well, in this case, a is 1. If you don't see a number out in front of x squared, it's just 1. So 2 times 1 makes negative 4. So from there, we take that negative 4 and substitute back in to find y. So y equals, we've got this negative 4, and we're squaring that number, and then plus 8 times by negative 4 plus 16. So we go ahead and do some work there. This makes a 16, and then we have plus negative 32 plus 16. So you know you're doing something right, we said, if 2 things. The x squared term and the x term are opposite sign and one's double the other, which is this case. And so we have negative 32 plus 16, ends up by having to subtract the 16 from 32 gives me negative 16. So let's fix that right now. Negative 16 plus 16 gives me 0. So the y component is 0. But I have to go 4 spaces to the left. So negative 4, comma, 0 is the vertex. So over 4 spaces, put that dot, and then use the parent graph. So again, the parent graph is this. It's the same as what we had on number 5 here. It's just a y equals x squared. So if you square 1, you're going to get 1. So from the parent graph, if you go over 1, you're going to go up 1. If you go over 2 spaces, you square 2, you get 4. And so over 2 spaces, up 1, 2, 3, 4. And you do the same thing on the other side, over 2, up 4 spaces. And then from there, you can draw your graph. And so there it is. So those are the first few problems that you'll end up seeing on the test. For 6, we'll go over the last 3 in part 2.